test. Oh, okay, wonderful. So, to get started, yes, I want you just to take, we just had all a coffee, we relaxed a little bit, we had a wonderful first 3 talks today. To just close your eyes for a second and listen to the sounds of nature here. What do you see when you imagine nature? Who sees like oceans? Jungle, green, forest, nice. Mountains, desert, people. So what I want to get with this point is basically that we often see nature as something green, something like that is there, but we don't see the people that are part of nature, that are often collecting, living, and depending on nature. And this data set that you just hear, the voice of the forest, the sounds of the forest, were collected by the indigenous Kayapo in Brazil. And I think this is a really big problem, that we're disconnected from the people that are living in nature, and therefore we are oftentimes taking away lots of natural goods and commons. And we see that when we feel and hear nature just now, we can all experience its implicit value. And nature is essential for human existence and good quality of life, but most of nature's contribution is really not fully like replaceable, and some are irreplaceable. And we see that when we talk about nature, that it's oftentimes coming from COP, of course, we'll talk a lot about carbon and carbon storage, but it's way more than that. It's like provisioning features, supporting features, cultural and regulating ones. And we have really not taken good care about this public common. We don't really value it. The natural world is actually deteriorating in rates unparalleled in human history. We're lacking tons of funding to preserve and fund conservation. And the question is why? So, of course, the United Nations and a lot of our policymakers know that nature needs to be funded, and they have pledged a lot of money into that. So this is called results-based payments, for example, for forestry. But the problem is that when you want to monitor the impact of natural world, or like if you want to measure nature, currently the measurement is really slow. It's overlapping land claims. There's a lot of trust that is not existing, which makes the funds inaccessible for the communities that just collected the data. So currently there's a lot of drive in data-driven carbon credits, where a lot of people want to collect tons of data from the forest in order to take advantage of this challenge and make an opportunity. And the problem here really is that tons of the data that is existing of forests, of course, are in the global south. And oftentimes the demand now is very high. But if you look at these 2 maps, on the top, this is the global GDP for the world, and on the bottom, this is like the amount of nature. It's basically a mirror map. So there are demands in the forest conservation community and policymakers to pay for forest data. So if you listen again to this one, this is a forest very close to the forest that you just listened to. And now you hear, for example, no birds. Quite silent and quite scary. And the reason why this is the case is this is a forest that just focused on carbon and didn't measure anything else. So this is a eucalyptus plantation that is only planted for forest and timber plantation. And this is what happens when you just measure one value and don't go to the field and collect data on the ground. So we kind of need to collect tons of data in order to properly value and protect our forests, to make sure that we don't do stupid decisions such as only funding monoculture forests, but actually value it as a whole. So we need to collect local data, like field-based data here, wildlife cameras from the environment as well. And the people who should collect it, of course, are the indigenous people. People are local community members that are living on the ground and should receive a payment for the data they're collecting. So the question is, okay, wait a second. Can we not just use remote sensing, measure everything from space? Why do we need to deploy really complicated human resources on the ground in the field? And the this is something we tested out. So our remote sensing algorithm is actually quite good enough right now that we can actually replace like human labor on the ground. And we looked at several communities around the world, one in the Philippines and Lobo Batangas down in the south, and then 6 sites in Ecuador where we measured every single tree and compared it to existing maps of carbon data sets that are derived from satellite imagery. So we went to the field in the Philippines, paid out local community members, 6 people for 8 days to measure 1,500 trees where we know and understand exactly what is the diameter of the tree, the height of the tree, the species of the tree, and given that these measurements, we can derive the estimated carbon that is on the area. So how that works is usually, it's very simple, and this is how all these carbon credit projects work. You measure the height, and you measure the diameter, and from that there's something called an allometric equation in environmental science that gives you an above ground biomass estimate per tree, and then you can basically aggregate that of the area, and then we compare it with the public data set that is derived from like remote sensing. And we can see, for example, when we do this, we can derive the above ground biomass density from this area, and we compare this with satellite-based data sets, and they are 9 to 16 times overestimated based on what we have measured on the ground. So satellite data is really biased right now, and that is not just in the Philippines. This is here the error rate, but this is also when you do this in Ecuador, we have overestimations based on current like remote sensing data that is just not acceptable to do proper policy methods and evaluation. And the only kind of like country that hits pretty well is the United States. And the reason is really, if you look at all the biodiversity data that is out there that science and the scientific community has collected over the last hundreds of years, and you would plot and resize the country depending on the biodiversity data, the world would look like this, right? Like most of the data has been collected in the global north, in North America, in Europe, and actually the place where most of the data that should be collected that is about nature, like in Africa, in the rainforest, in Congo, or in the Amazonas, is not connected. And that is, of course, due to lack of bias, infrastructure, lack of resources. So the idea here is really, okay, can we design, based on the lack of data that is needed to improve these algorithms, to make them more fair, more equitable, can we design a framework, a principled framework, that values data and pays out local communities for collecting it? So we looked at existing data valuation approaches in the past. How did people value data? There's, for example, query-based approaches where there's just a flat price on demand, Cotres et al. From 2012. People did auction-based data valuation and model-based data valuation. But really the question we want to answer here is, given like X dollars, how should each data point be paid out to reflect its value, right? So our desiderata for kind of this data valuation would be like follows. Well, it would be nice to just have something that is combinatorial, because data often comes in multiple sources. We will see in a second, especially in nature, it comes in multiple different kind of varieties that are really hard to align over. It would be nice to have a task specific, so maybe the value of the data or the payout of the data should depend on the task it is trained for. And of course, it should be cumulative. Data point can be used multiple times, and equitable, because the same data point that contributes exactly the same output to one algorithm, and if there's another data point that does exactly the same, it should be a symmetric value. So we looked into this, and we thought, okay, combinatorial game theory, cooperative game theory is quite a good place to start here. So we take the task as a machine learning output. Okay, we want to improve this machine learning algorithm that is currently lacking in like accuracy, as we saw on carbon estimate, because it's lacking the data. How can we model that potentially as a cooperative game in order to incorporate all its potential combinations? So what we came up with is basically on the left side, each data point is a layer, and then the algorithm itself is a utility function that evaluates its performance on a specific task. That could be like the validation data set of like how good it is to predict this cat. And then you can model this as a cooperative game that is played among these players, which is each data point a single player. So task-specific, we reduce that into a profit allocation problem. Basically, okay, the machine learning model provides a certain kind of profit, and that needs to be rationally equally distributed back to the data points. And then for cumulative and equitable, what allocation scheme basically we are asking satisfies all these desiderata? And it turns out there's only one unique solution, which is the Shapley value, that satisfies these 4 properties. And the Shapley value is straightforward. It's basically given a number of training data points, and like let's say D is the training data set, and S is a subset of the data set, except for the player set V that we want to value. Then what we do is basically we input that data point into a utility function, which is the algorithm, the machine learning training, or the validation data set, and we calculate the marginal contribution of that data point. And what it does is basically it does it on average for that data point. So the average of all possible subsets, what is the marginal improvement? And Shapley has shown that this actually satisfies several properties. One is it's equitable, so every data point that does exactly the same impact will have the same value resulting from that, and it's cumulative. It has this really nice linear property. So the problem with this approach, though, is evaluating U, the utility function, because it's the machine learning like training and task, is quite expensive. And by itself, Shapley is already has exponential complexity, so that doesn't properly scale. So what people have done in the past to improve Shapley computation is basically approximated as an expectation of the average, so expected marginal contribution, and then you can just take some random subsets, and you get some, using Monte Carlo approximation, some approximation boundaries. And then you can see, for example, that this is an epsilon delta approximation to the true Shapley value. So for machine learning specifically, and that's actually the beauty of formulating the Shapley value as formulating a machine learning task as some kind of a cooperative game, is that these utility functions are now specific to certain kind of machine learning tasks. So we can leverage the specificity that machine learning has in order to speed up the algorithm even further. One, for example, we can leverage several characteristics. We can we can proxy the utility function. We can say, for example, assuming that the utility function has certain kind of like properties, like locality, like maybe it's a k-nearest neighbor, we can improve the algorithm. Or if the utility function is kind of differential private learning, it has a stability feature properties, then we can also improve the computation. So let's look at k-nearest neighbor. So assuming that the utility function is a k-nearest neighbor, all we need to do is actually just, given the training data set, and we want to compute the Shapley value of a certain point to the training data set, we need to just query to the query point, sort the training data set, and then compute a majority rule. Sorry, that lags. So basically, the intuition is here, when we leverage the locality of the algorithm, then many of the subsets, let's assume one nearest neighbor, many of the subsets, when you, for example, want to add that point into that subset, is 0, because it's not going to be considered anyway in the Shapley computation. So this is 0, this is 0, this is 0, this is 0, for example. And all of these are 0, so we don't have to consider, we don't have to try out everything else. And we can derive a decently fast algorithm that can provide us the exact Shapley value, given that the algorithm has a certain kind of locality property. And the algorithm looks like this. So we sort it once, and then we calculate it recursively using this function. And it will provide us ON, and the sorting itself is n log n. So we can calculate exact Shapley values, given that it's a k-n algorithm, in n log n time. And that's, of course, much faster than if we would do it like brute force, where we know we have to exponentially evaluate the Shapley value. So it's 2 to the power of n, and then we need to sort it every time we do this. So that would be the baseline that we compared given the K&N Shapley algorithm here. So that works on millions of data points, and we tested it out. For example, if you have 10 million data points and you assume a K&N Shapley value on 152 gigabytes, it would take 44 seconds on a single machine to compute the exact K&N Shapley on this data set. And that is much faster than we would run, for example, Monte Carlo sampling. More work has been done since then. So that's a list of more data evaluation algorithms that have been published and discussed. And I'm looking forward to the talk of Brian, who will introduce some of them. But now I really want to show you from, okay, we have this really nice framework where we, okay, decided some on desiderata. Now let's go to the field and see if we can implement that and what do we learn. And we are partnering basically currently with 23 organizations on the ground, paying them with this Shapley-based approach. They're collecting data. We're computing the value of the data given some certain machine learning tasks and paying them out back. And what we see is there's a lot of challenges that are coming out that are not considered before that I would love to introduce this to the community, see if there are certain kind of approaches that could be used to tackle this. The first one is that when we value, the infrastructure of data collection is very crucial in the given system of designing these incentives. For example, many of these communities don't have proper internet connection, so the data collection itself will happen in a delayed process. So we implement certain kind of technology to allow them to go into field, collect pictures of trees, but that needs to be very robust and offline. And that's, for example, how it looks like when you go to the field and you want to upload the data. Oftentimes we provide them with the mobile phones, and the upload itself is delayed. So that's a challenge. What we do then is basically whenever we have internet, many of them are unbanked. So we are connecting them with mobile wallets on the blockchain in Web3 and pay them out in crypto for now. And we have local partners that then directly translates that data payment into their local currency. So the problem here is also that when you provide the Shapley value as a payoff method for these communities, there are certain kind of problems that come with it, even though it comes with really nice desiderata, that makes it unsuitable on the ground and in the field. One is, for example, that community members might not understand it. It's kind of, even though it provides us with these wonderful guarantees, it's not clear to them, and it's kind of hard to interpret. And that causes, for example, when we're in Ghana and we are paying out with the Shapley value, a lot of mistrust. One of the things we also learned when designing these data payout games is that when you pay out the money only once and you don't communicate that it potentially could be a repeated game, that there are certain kind of incentives that will steer towards gaming you, right? Because like you're one of these people who will basically come to the ground again, promise them like some money for their data, and you might not come back. So there's a strong incentive to cheat on you and take most advantage of you, while compared to what we learned later on, when you promise them that it's a repeated game, like you come back and back and back, it will steer the incentives towards a more favorable position for you. Also, paying out people is not necessarily a strong incentive. In many of these communities, there are incentives that are non-monetary. For example, collecting data itself can be used as a cultural, social, and educational benefit. Elders could walk around, show youngers like the forest and the area, engage in like culture exchange. So there's a strong incentive actually to do this if you design these programs not only with a monetary incentive in mind, but also in a cultural context. We always think we can sample the whole area like in whatever way we want as someone like as a person from statistics, but in areas that are, for example, based on nature, certain kind of parts are completely inaccessible, and even if you want to explain to them that it makes sense to go in this area, they will not. So here in the rainforest in the Amazon, for example, we can only sample in the blue paths, which are traditional paths, and not the other paths, because it's just inaccessible, there's no willingness to enter, it's just a lot of hard work. So that's also something to consider. In the end, of course, we work with a lot of different kind of data modalities, so how do we fuse it? We see that several approaches, when we fuse them together, of course, make more sense and improve the accuracy of algorithms. But then on the other hand, if you fuse modalities that are image and field-based, you will come to problems that are alignments. For example, like predictions of bounding boxes of trees won't align properly with GPS coordinates of the collected data points. So this is going to be also a hurdle when it comes to different kind of modalities to combine them together to make them effective. And one of the things we also observed, we provided them with drones to collect their own drone data, that there is incentive to cheat and to pretend like that the area is, for example, more forested than other areas, especially given that when the forested area is paying you more than not. So there are attack vectors to modify these images from communities when it comes to decentralized data contribution. And then the question is, okay, how do you prevent these attack vectors? And we had some work on metric learning and classifiers to classify if a drone image is very similar to a satellite image, and assuming that the satellite image has a higher trust, we can trickle down the trust to that decentralized collected drone image, because we can basically classify if it's the same or not. Okay, I'll skip that. And one thing which is also really interesting is that these communities have wonderful knowledge that is really hard to access and structure traditionally. So for example, this is a participatory mapping of all the Brazil nut trees in their location, and it's written on a map, so they can just produce it. But then when you really want to leverage that into machine learning algorithms, that's kind of an unsolved task. So one of the things we noticed, for example, when we compared the locations with satellite data, is that these trees stuck out. So we could extract some visual features to train a CNN, but they have so much more wealth of this knowledge, and it's really like an open research question. How can we properly structure that wealth back into our busy digital systems? Last, data ownership. This is traditionally something that when we talk about hospitals, the hospitals want to have the data based in their hospitals. And in nature and indigenous communities, we have a similar scenario where it's really, really difficult to basically collect natural data in communities and transfer the data into European or US American servers, because it will potentially create ethical conflicts and also like conflicts with policymakers. So there's a strong incentive to keep the data locally stored. So with that, I conclude. I think there's a lot of future work that we can look into, for example, how to fuse more and more upcoming data modalities into the system, and also ensure that as technology is getting better, how do we still can maintain fair data payments to local community members, don't make them obsolete, because much of their contributions are really valuable to steer our systems properly, to make them ethical, and to also benefit these communities on the ground who are stewards of the forest, and that would be a wonderful way to preserve and contribute to conservation. So I'll skip that. These are like new methodologies to collect biodiversity data, and I'll end with, I'll end with this slide. So some lessons learned on the ground trying to implement data payments is we need to be transparent and open when communicating the data payment strategy. So the payout game influences a lot the behavior and gamification elements of the local community members. It's really important to co-design the game with the local communities, especially when it comes to data ownership, to scenario-specific utility functions, and build tools that satisfies them and not just build tools that no one else is going to use in the end. And I believe nature conservation is a great place for the collaborative learning community to look into that is outside of healthcare, and is still unexplored and can provide a lot of interesting last mile problems that arise a lot of now interesting research questions. So thank you so much for your time, and I'm open for any questions.
Yeah, while the mics reach.
Yeah, I think it's great to pay people for data and really critical.
Thank you.
For other works of, creative works of various kinds, people get paid over a long period of time.
Yeah.
So it's hard to value your data from the get-go. I don't know how valuable this could be, but maybe it turns out to be really valuable, and some downstream user, it just becomes more and more valuable. So you would like to have the ongoing stream of revenue. You'd like to have provenance. You'd like to have a whole infrastructure set up. I'm just wondering how much you've been thinking about that.
A lot, actually. And I believe this is one of the critical, I think even almost groundbreaking ideas of paying for data in conservation, is because right now conservation has two ways to finance itself. First, donations, which is not scalable. Second, forest carbon credits, which we saw officially. Creating actual value in the digital economy and maybe charging an API that can pay a subscription fee and that pays back to the community members who collected the data is a predictable potential income source that will last longer than donation of forest carbon credits. So the question here really is, I talked a lot about the supplier side. These are the people who provide the data. I didn't talk a lot about the demand side. Where does the demand come from, right? And that's something that I've been thinking a lot. Demand can come from pharma companies, because many of these, especially indigenous wisdom parts of plants are medicinal purposes. That is right now unstructured. Like, we don't know anything about the Amazon. The Amazon is the size of Europe in the continent that is the least known continent in the world, and that's the least known area of that continent as well. So there's a lot of knowledge that's gathered for pharmaceutical interests, for example, that we can take and benefit in. So if we can solve the demand side, I believe it will be as simple as a database of who contributed the data and a paid API access that basically channels the funds directly back to the people who contributed. Because if you can track the provenance of each data point into the database, you can distribute the money back.
So you mentioned differential privacy, and I was wondering if, because under differential privacy, you bound the contribution of a user or a training example. And then the payoff is going to be a little weird because everybody would be essentially contributing up to that epsilon leakage by differential privacy. Have you thought about it, how to incentivize in that regime?
Yeah, so when the algorithm is stable, like it has a stability property, then as in differential privacy, you can less track a single individual contribution. The values will basically equal to each other.
Yes. So I can imagine that for each of this participation, you will have different participants coming in at different time.
Yep.
So how do you value them, right? Acknowledging the fact that they actually come in at different time and they may leave. Yeah.
Absolutely. So that's actually one of the big open problems. Like if you want to make it a repeated game especially, and you have different participants coming different times, right now we do a non-perfect solution. We basically cut it and batch it again and recompute it, right? I think there is much more efficient ways. We can cache previous results. We can derive them from, but as of right now, this is the like most stupid way we're doing it.
I guess one comment I may have is, for the issue on repeated payments, this is something that we see in federated learning as well, especially if you want to look at all the various iterations, right? Where in the earlier moments you may contribute more, but towards later you might not, and vice versa. So maybe some literature from that aspect in terms of payments would help. Yeah.
Mm-hmm. The problem is, and I really like your work on this, is that the shareware itself is not robust against potential attacks, right? That would incentivize a duplication attack. is a classic one to basically, you can just duplicate the data millions of times, and then because of the fairness property of the Shapley value, it will be all the same value, right? So these are the things that we need to consider when designing like first come, first serves, like incentives, but it's a really good point.
Can I ask Alan to set up, the next speaker to set up the, oh yeah. Are there any questions while Alan's setting up? Maybe I have some, one, I guess, easy question is, have you seen any measurement of the influence of these benefits of implementing these kind of systems?
Yeah. When you do one-time payment, people cut down the forest afterwards because they don't expect you to come back. So the reason we do this is, of course, first, there are two things. We want to improve the algorithms that are lacking accuracy right now, but then also we want to generate an understanding for local community members that this tree pays you, so you better not cut it. So if it's a one-time payment, we saw that after 6 months, they're just gonna cut down, like it happens very much that they cut down like parts of the forest for a parking lot, which is unfortunate. So a continuous repeated game actually so far has been much more successful in preserving certain areas than when it's like less better communicated. So I think communication is really, really key. Trust is really, really key. Local, communities in the Global South has experienced so many one-time games that they've got enough of it. So really the thinking has to be in repeated games. And as Michael said properly, it's really difficult to value that in the future, but potentially you can escrow some money, promise them that when you start the relationship, and then over time distribute it in small steps.
Reputation systems.
It will also be cheaper because the incentives is not as strong to cheat you, right, as it's repeated.
Thanks so much, David.